Have you ever wondered what the cool kids are talking about when they're talking about reactive programming, reactive functional programming, RxJS, RxJava, and all of this jazz? I have, man. I've been wondering about that. And so that's what I thought we were going to talk about in this video. Not necessarily what is reactive programming, but what I want to talk about is, in order to understand what reactive programming is, let's try to build our own library for reactive programming using JavaScript, just very simply, right? And because in my mind, it seems like building something from scratch is actually a great way of understanding how something works and what you can actually use it for. Now, as a precursor, or as a disclaimer, I haven't actually used RxJS or any of the reactive libraries, but I had a bit of a look at the API for JavaScript for RxJS, and it just seems like the thing I'm about to not necessarily propose, but what we're going to talk about today just seems like probably the way that they've done it. Maybe they've done it slightly differently, and if you are sort of a hardcore RxJS user, I'd be super happy if you could outline maybe some of the differences between what we've been looking at or what we're going to look at today in this video and what actually happens in RxJS. But stick around, man, because this is going to be some cool stuff. It's actually, I'm actually kind of surprised about how simple it is to actually get something like RxJS, assuming that my understanding of RxJS is correct, up and running. So yeah, it's pretty cool. We'll jump into this in a second. I just want to say that if you aren't sort of like, if you have zero idea what reactive programming is, and if you early on notice that I'm not making any sense, or that I'm not sort of that you want to sort of take a step back, then maybe go to this website and check out the introduction, because here you have some discussion on, like, for example, why use observables and all that stuff. But hopefully you're not going to need that. Hopefully what we're going to talk about in this video is going to be enough. And now let me just say what motivated this video is that I was actually working on this other video, which is the sort of mini series where we're building a mandala maker, right? Maybe you've seen that. It's a coding challenge, and in that video, I wanted to have multiple pens that are drawing on a canvas, on an HTML canvas, right, using JavaScript. And I say multiple pens like metaphorically. What I mean is that, like, I have 2 points, let's say, and both of these 2 points, I want to update them, right? I want to update them on the basis of one number, and so from that number, I'm sort of deriving the 2 updated points, but then I want to draw both of those from their original points. So it's kind of like we have these two, we have like one incoming stream of data, and then we have 2 things that are observing this incoming stream of data. And so the incoming stream of data is essentially then the mouse position of the user, right? The mouse position on the canvas. And as the user is moving the mouse, that's an observable. And then the pens are observing that, and then they're updating their state on the basis of that. Or, not necessarily updating their state, but it could be that they're updating their state. And then I just started to think about reactive programming, and then I thought, yeah, okay, it's time. This is probably a scenario that would be very suitable for reactive programming. So we'll see how far we get in this video, and maybe if we have time, we'll look at that as an example, or a simplified version of that. But yeah, and if you want to think about it in another way, you can think about, so Gary Bernard has a now very old talk, or pretty old talk, but very good talk called Boundaries. It's available on YouTube. And where he talks about this idea of having a functional core and an imperative shell. And I don't know, maybe a lot of other people have been talking about that idea as well, but it just seems to me that if I take a step back, what I mean is this. If we talk about functional programming, there seems to be sort of 2 ways of introducing mutation into functional programming. Either you decide to be pragmatic and say that, okay, I'm going to allow some level of mutation, and then you keep that level of mutation very, very controlled, and you keep it sort of at a shell layer, hence the functional core and the imperative shell. So it's like all user interaction happens outside here in the shell, but as soon as possible, as soon as we get into complexity, we just dive down into the functional core where everything is functional, where we're just invoking functional programming functions, or like pure functions essentially. And that's sort of one way. And the other way is in terms of thinking about, for example, monads. Now, of course, monads also then, I guess, sort of model mutation, right? It's a pure model of mutation, if I'm not mistaken. But it seems that, I can't actually have an opinion on that, because I don't understand monads enough to actually have an opinion about how useful, or rather, I should say, how simple monads are as a programming model, when it comes to dealing with mutation in, let's say you're dealing with, for example, a drawing application, as we were talking about now before with the Mandala Maker application. But it seems to me that we sort of have these two very quite boxed solutions that both seem like pretty good solutions. Either we use sort of mutation in a very shell-like layer sort of on top and we keep control of it, or we use state monads. And yeah, I mean, reactive programming is then one way of sort of dealing with mutation, introducing mutation, or introducing an imperative shell around a functional core. So something that is actually mutating stuff, but if you're only mutating very, very few things, and if you're only mutating things in regards to your, let's say, observers of observable streams, then hopefully it's going to be pretty, let's say, controllable. Hopefully you're going to be able to keep your application in check, right? Because that's the fear, or that's the problem all the times, where we want to stay away from applications that become where complexity grows unmanageable. So anyways, let's jump straight into it. Hopefully that's sort of a sensible introduction as to, or into, why we are doing this and like what the heck we are doing. So let's just jump straight into it. Let me full screen this terminal and let's dive into it. Let me clear this. Let's jump into Vim and let's create an index.js file and let's just work with that. Okay, so what are we gonna do, right? I think we need to think about a scenario, and I don't think we want to think about the drawing of a pen scenario. I think we want to think about something simpler. So let's say that we had a variable called an observable, right? And let's say that we could observe that observable. And so let's say we could say observe, right? Or actually, let's say maybe subscribe, right? Let's say subscribe. So that I noticed from when talking about observables in C# that I really like the sort of duality of observable and observer, but I tend to get confused when making videos, and I mean one but I say the other and all that. So let's just separate them and say subscribe. So let's say that we had a subscribe method on that. So we're just thinking about sort of like what's the use case here, and then maybe you get an X. So that subscribe method, instead of subscribing with the data structure, like if you think about observer pattern in C# or in Java, then you would have observables and you would have observers. And when you subscribe, then you would pass the observable an observer. So that would be a data structure. But here, instead of having an object, we're going to say that subscribers are functions. So observers are functions, but observables are objects. So the observable has a subscribe method. Okay, so we subscribe on that, and that thing is going to emit messages, and let's call that message X. And then we're just going to say, let's console log that message, okay? So that makes sense, right? It's like we have this observable thing, we can subscribe to that thing, and that thing is going to emit messages. Maybe let's make the font size a bit bigger. Okay, so fine. Now, what is the observable, right? So let's say const observable is what? Is, I guess, a new observable? We don't really know what that is yet, but that explains why we can say .subscribe, because it's an object, right? Oops. Okay. And yeah, I guess nothing more to this, right? Of course, this we could rewrite using bind so that we're not actually mentioning this variable, but let's do that in a moment. Now, this would probably, like, even if it was possible to observe this observable, nothing would happen because the observable is not emitting anything. So let's say what we also expect is that we could say observable dot emit, in other words, to send some data, right? So think about this. It's like an observable that can emit data and observers that can observe this emitted data. So let's say that we emit a bunch of numbers, right? First we emit 10, then maybe we emit 1, and so forth, and then we go 2 and 3 and 4, right? Okay, so we're emitting a bunch of data. Now, of course, this won't work because we don't have the observable data type. Let's actually type this out and then let's think about it. So let's say there's a class called observable, all right? Let's say that has a constructor. Wait, do we need a constructor? Observable, yes, we do, okay. Why do we need a constructor? Well, we need it because the observable can have observers. Observers can subscribe to the observable, which means that this needs to keep track of observables. So let me call this OS, right? So usually we say X's when we're dealing with functional programming to emphasize that I have a list of things, but here I'm just going to say OS to emphasize that it's a list of observables, right? So it's a list of something that starts with O. And then we need to have a subscribe method. Okay, and this subscribe method takes a function, right? It takes this function, which is this callback function here, right? That we're passing in. So maybe instead of calling them observers here, maybe I should call them, maybe I should call them CBS for so like callbacks or something like that. So then subscribe is being passed a callback, right? That kind of makes sense. And then we say this.cbs.push CBS. Oops. Now you notice, right? I mean, it's like, well, I thought you were going to talk about a functional reactive programming. Now you're using mutation. Yeah. We're using mutation. We're using mutation because this is the imperative shell, right? It's like we're not worried about staying pure now. We're worried about having a simple model that allows mutation, or that actually mutates things, so that we're able to, for example, do things such as receive and send data to over the network, or do I/O, or interact with the user somehow, right? Like with the mouse clicks or keyboards or whatever. So we can push here, right? Because this observable is actually mutable, right? You actually push in observers into this observable. Okay. So then we have subscribe, but then we also said we have emit. Okay, so then we need to have emit. Okay, so what is emit? Well, emit can emit some kind of message. Let me just call this X. It's just some message. Okay, so what does that mean? Well, that means that we should notify all of the subscribers of the existence of a new message, right? So that means we should iterate over all of the subscribers and then just tell them that here's a new message. And of course, tell them here means invoking the functions because they are callbacks. So that means we need to do this.cbs, which is all the callbacks, and then we need to map over that. I mean, it's a for each, right? We could do that, but we could just as well do a map, doesn't matter. So we map over that, and then each of the elements are going to be a callback, a CB, right? A function. So, and then we just apply that CB to the new data that just arrived, right? And if you've been watching my other videos, you might know that this is also, or I mean, you might know for other reasons as well. We can use the Thrush operator here. So you can define a general purpose functional programming function called Thrush, which takes an X and then it returns a new function which takes an F and then applies that F to X, right? So that would help us simplify this particular implementation here. So instead of actually explicitly naming the CB here, we can just say that we map using Thrush onto the X, right? That's the same thing, right? But it's really, it's the same thing as saying this.cbs map X, CB, and then CB applied to X. Same thing, which is of course also the same thing as saying something like for each. I mean, not exactly the same thing, but in our case, it has the same effect. It has the same effect as saying like for each var CB. Is it of in JavaScript? I think it's of. Maybe it's not for each even. Maybe it's for. I don't know. Like let's say for each. Okay. I think you understand what I mean. Like just let's say. Pseudo syntax, right? For every CB of this.cbs, then we're gonna do this.cb, or sorry, no, call the CB by passing in X, right? That's essentially the same thing as well. But we're gonna use this Thrush syntax, right? Because that's fairly well or compact, right? So this seems like something that would work now. Let's try this out. Maybe this works. Let's map a keystroke to running this file through Node.js. And let's run that and let's see what happens. Hello? Wait, nothing happened? Oh, wait, actually, my terminal is going crazy. Let me clear this out and see if that sort of sorts it. Yeah, I don't know what happened. Sorry, my terminal went crazy. It seems to be working anyways. So you can see here, we get 10, then 1, then 2, then 3, then 4. Okay, why do we get those? Well, we get those because we said subscribe, right? Add a subscriber, and the subscriber is this function, and this function says that whenever I get an X, I want to console log it, right? So that's why we're printing all of them. And I mean, of course, we went through a lot of hoops in order to get that, right? But the value of this is that we can now subscribe using any function, and we can add multiple subscribers. So if I duplicate this line so that we're doing the same thing twice, we're subscribing once, and then we're subscribing again, right? If I save that, let's run it. then you can see we get 10, 10, 1, 1, 2, 2, 3, 3, and 4, 4, right? Because every time there's a value, we get 2 of them. Now I added another one, and then we get 3 of them, right? And of course, it's completely arbitrary that I'm choosing console log here, because you might want to do something completely different, right? So what could we do now? Well, now we could start to do a bunch of stuff, right? Let's say you can subscribe, but that means you could maybe do a bunch of things, like whenever I have a value, right? Let's say I have this x, then maybe I could first, like, let's say there's a function called double, which has the implementation double, given some x, just does x times 2, right? So maybe I first double it and then double it again, and then I will, oh, sorry, yeah, actually, I'm past the x, right? Sorry, so actually what I mean is, first I double it here on the inside, and then I double it again here on the outside, and then maybe I console log that, right? So let's try that out. Now we only have one observer, right? It seems to make sense. First number was 10, now we have 40, because we're doubling and then doubling again, so up to 20 and then to 40. And then this next number was 1, and then we have 4, right? So that seems to work, right? And of course, since we're talking about reactive functional programming, let's talk a bit about the functional programming part, right? So we could maybe here use a pipe. So if we had a pipe operator, then we should be able to say something like this: subscribe and pipe, and do double, then console log, right? Something like that. Of course, let's try something simpler first, right? Let's move towards that, but let's try something simpler first. Let's just get rid of the x first, right? Notice that when I said pipe, we are not specifying this initial x, right? This initial argument. So shouldn't I be able to say something like this: console log observable subscribe console log? Let's save and try that. That works, right? So we don't have to specify this initial x and then just say console log x, right? That's like with piping in functional programming. Whenever you have a function that looks that just says immediately invoke the function with the argument that I was passed, then you can just specify the function, because you're sort of just applying that argument directly to the function. So okay, that's cool. We can specify it like this. We can just say console log. So that means we should be able to say pipe, let's say console log, right? Let's just add another layer of indirection. So let's say we have a pipe function that takes a function and then some x, and then applies that function to the x. This should work as well, just works as well, right? But that's not actually what we want. What we want is that we want a bunch of functions. Let me call them fs, so for functions. And then I'm going to spread over them, right? And this is going to be a bit hairy, right? So I'm not going to go into details in explaining everything, but think about what happens here, right? We're going to use reduce in order to actually implement pipe such that it works on... Actually, sorry, what I should do is I should first do this. We should do the simpler scenario. What if you have a pipe function that has an arity of 2? So if you have a pipe function that first takes some function f, then takes some function g, and then takes some value x, and then applies the function f first, yes, and then to x, and then, given the result of that, applies g to that, right? So this means we should be able to express a pipe now. Let me break some lines here to make this perhaps a bit more clear. We should be able to express a pipeline where, let's say, first we double and then we console log. So let's try that. Okay, this did not work out. Why not? So maybe this is because of binding, or maybe I'm messing something up. Hang on, f, g, yeah, sorry, okay, sorry, arity of 2. So I expressed this as a curried function, but I used it here as a function with an arity of 2. So let me use this syntax instead, right? We need to have an arity of 2. Let's save that and let's try again. That works, right? So now we're doubling first, and then we're console logging. Okay, that's cool. Is there a problem with this? There is a problem, and that's if I do console log twice here, then the second console log will not have a value, because think about this syntax, right? We're first applying f to x, and then we're applying g to the result of applying f to x. But if I apply console log to x, then I'll get void back. I'll get nothing back, right? Because it's a mutating function. It just prints the screen. So now we get undefined, right? We were expecting to get 10, 10, 1, 1, 2, 2, and so forth, but we're actually getting 10 and then undefined. So this is not good, right? So what we need to do is we need to introduce something like tap. Right? So tap is a function that, let's say, that performs some side effect and then returns the thing that you were given initially. So it's kind of like identity. It's kind of like identity, but it's also performing a side effect, also known as do, right? So maybe we should actually call it do. So I'm sorry, actually, I don't know if it's actually called do. Maybe do is more from Monads. So let's just call it tap. Sorry. So tap, given a function, right? And this function is the side effect function, the thing we want to do, such as, for example, console log. And then the value that we want to get is x, right? That's the second argument, but we're expressing this in a sort of curried fashion. And what do we do? Well, what's the implementation? The implementation is that first we do we apply f to x, semicolon, and then we return x, right? Notice how we have to use this syntax now because we're actually doing two things. We are like performing the actual side effect. We're doing f, right? We're doing f given x, and then we return x, right? So we do this just in order to be able to console log, so in order to be able to express a side effect, but still continue the pipeline, right? And this is again back to this idea of that now we're pragmatically allowing mutation, but we're sort of trying to maintain the power of functional programming, and we're trying to keep control or keep our mutation in check. So now if I say tap console log here instead, that means we're gonna do console log, we're gonna perform the side effect. Like it's in some sense it's like we're forking the pipe. We do the side effect, but then we also return the value that we had before, so that we can console log in the next line as well. So let's try that. And now it works, right? 10, 10, 1, 1, 2, 2, 3, 3, 4, 4. Cool. And if it's the last item in this pipe, then of course, then that thing can just say console log. But I mean, for good measure, we should probably say tap instead here. And that works fine as well, right? Okay, so that's cool. Think about this now. Pipe is now taking two arguments, but we want it to be able to take any number of arguments. We want it to be variadic, right? Just for the sake of simplicity. So think about how you would do that. Let me just drink some water. So we can do that using reduce, right? And again, like I think I have possibly other videos that deal. Yeah, okay, sorry. If at some point you feel that you're confused in regards to the functional programming that I'm using and I'm not sufficiently explaining it here, I apologize. Please check out my Ramda series. There are tons of videos there where if you follow through that series, we go through lots of details that probably help in understanding, for example, this video. So how would we do this? Well, let's just write on a new line here. So let's say the new pipe function, instead of taking an f and a g, we want to use the spread syntax to say we're going to take any number of arguments and we're just going to collect that in the array fs. Okay? And then we're going to take some x, of course, still, because we want to have some input. We want to pipe that through this series of functions. And what we're going to do, it's actually pretty simple. What we do is we say, take this array of functions and reduce over that, right? Fold over, left fold or right fold. That always confuses me. Left fold, I guess, is the point. Fold over this, reduce and fold, it's the same thing, right? Reduce over this array of functions, and consecutively we produce a new value. Like it's like we're sequentially applying a single function at a time and then keeping track of whatever value we've produced so far. So in some sense then we're saying reduce, where every value here will be a function. We're going to simplify this, but let's do this first. Where every value is going to be a function. And what we do is that we take that function. Oh, sorry, actually, reduce takes, of course, a function that takes where the first argument is an accumulator, and the second argument, I was thinking of map. This is why I was doing the other thing. So we take, so reduce takes a function, right? And this function takes two arguments. The first argument is the accumulator, and the second function, or the second argument is the current function that we're at in the reduction of this array of functions, or in this fold of the array of functions. And so ACK here could maybe sensibly be called value, because that's like the value that we're building up to. Like in the beginning, it's the input, and then in the end, it's the output. But let's just call it ACK, right, for accumulation or accumulator. And what we do is just we apply f to the accumulator. I believe that's it, right? We apply f to the accumulator, and then comma, what's the starting value, right? What's the initial value that we start from? Well, that's just x. Of course, right? Because we're piping a list of functions, or sorry, we're constructing a pipeline by saying that we need to reduce over a list of functions by applying each of these functions to whatever value we're currently at, starting from the initial value x, and then we'll get some value back out. So let's just save that, right? I think maybe let's make sure that we don't have syntax error first, that we do. So pipe is, oh, sorry, of course, because I defined pipe twice now. So I removed the old implementation of pipe. Okay, so the old stuff still works. Let's make sure now that our pipe function works independently, right? So let's do something like, I don't know, like, let's say we have the double function here, right? So maybe let's use doubles. Let's say console log, and then we're going to say pipe, and the first function we're going to do is double, and then we're going to do double, and then we're going to do double, and then we're going to apply this to, let's say, the value 10, right? So what should we get? First we have 10, then we have, first we have 10, then we get 20, then we should get 40, and then we should get 80, right? That's what we should get back out. Yep, and that's what we get back out. Let's add a divider to make sure that we are indeed looking at the right number. Yeah, the number up here in the top is 80. So that seems to work, right? And if we add a bunch of things, you know, we actually we perform all of these functions. And of course, I could skip console logging the result of the pipe and just put a tap console log into the pipeline. We could say tap console log here, right? Then we're tapping out the last value, but we could also tap out sort of values in between. So let's say we're tapping out, I forgot a bunch of commas. After every transformation, we're showing the value, right? And maybe I could show the first one as well, like this, right? So we're saying the first one is 10, then we're at 20, then we're at 40, and so forth, right? So, okay, so now we have a functional pipeline. So super cool. So we can actually use that to work with what comes out of an observable, right? So let me try to find my way back here. Actually, let's clean this up a bit. Let's take these things, tap and pipe, and put them at the top of the file, right, where we've put Thrush. And let's maybe add a comment here to say general purpose functions, right? Because those are sort of, very general, right? They have to do with functional programming stuff, essentially. Maybe let's actually do this. Let's add another file and call it or base, right? Let's say, or actually let's call them prelude, right? As in, like, I'm just thinking of Haskell, right? So prelude is this collection of basic functions that we're probably going to use throughout the construction of this library. So then here in the top, let me say, sorry, but then so messy, right? I was thinking of, yeah, but then I need to export these functions, and in the end, I probably actually want to work with this in a index.html file. So I was expecting to just publish everything as globals. Ooh, should I split this in multiple files or not? Yeah, okay, sorry. Let's do this, right? I'm sorry. Sorry. Let's put everything into one file. So we have these general purpose functions up here, and then we have the observable stuff. So let me add another comment here, and let's say observable, right? Or let's say reactive library, right? And then let's add another comment further down here where we say something like example, right? So now we've sort of divided our code into three parts. We have the general purpose functions, the reactive library, and then we have some example that we're running here in the end. Okay, super good. So what are we gonna do now? Well, now we can subscribe and then do a bunch of stuff, right? As we said, we can do, for example, we double, and then we double, and then we tap console log. So whenever we get a new number, then we're transforming that number, and then we are printing that number out. Now, the question is this: what if you want to perform operations sort of across the whole stream, right? Or what if you want to I'm trying to think about how should I express this scenario, because actually, if you have a transformation that you want to perform, it's tricky for me to find out how to, or to figure out a way how to motivate what the need is. But essentially, I'm trying to get at what is known as operators in RxJS. So here's maybe another way of thinking about it. Either we could say that whenever we subscribe, there's a function that transforms the values that are being spat out, right? That are sort of being emitted. But another way of doing this would be to say that we have an observable that observes another observable, right? And then when that first observable emits something, the second observable will react to that, perform some potential transformation, and then maybe let that value through, or maybe not let that value through, right? So double, I mean, in some sense, if you think about it, what we're doing here is that we are mapping over every value. If you think about like this emission of a bunch of values, think about this, like we're emitting 10, then 1, then 2, then 3, then 4. It's kind of like we have this array of 1, 2, 3, 4, or 10, 1 through 3, 4, right? But it's like a lazy array. It's kind of like this array that is asynchronous because we don't know when we'll get all the items. So we'll just sort of take one by one. But it's kind of like we have this array that we're calling map on. And the function that we're mapping is the piping of double, and then double, right? And then actually like a tapping of console log, right? Because we're printing each of these numbers. But it works fine if we have map. But what if we have something like, let's say, filter? Let's say we have, let's say, observable.emit -1 here as well, right? So let me just run to make sure that this works. So now what we emit is that we emit 40, 4, -4, 8, 12, and 16, right? So what if we wanted to say, don't emit any values that are less than 0, let's say? How would we do that? Can we even do that here, right? Because we're subscribing, and then we have to run this function every time, and we have to produce a value. Let's say, like, I mean, now it's silly because we're tapping here. So, I mean, I guess I could put something like this. I guess we could put a function here that says the value is x, and then here's the implementation of this function. Right? So maybe like what we're looking for is maybe to tap if it's greater than if it's 0 or greater, and to not tap if it's not. So then we would say, well, if x is less than 0, or actually, yeah, greater or equal than 0, then tap. Right? Let's just do that, right? But actually, we need to return a value anyway, because if this is a pipeline, then who knows, maybe there's something else that should happen afterwards. So if we don't tap, then what are we supposed to return, right? It's like you can't really filter, right? You can, of course, I mean, if you start to work with something like maybes, like if you work with the maybe type, then you can. But there's also a completely alternative way of doing this, and that is to sort of compose observables instead. It's sort of to pipe observables into each other. So what I mean is this. What if we instead of doing what we did now, did something like this? Observable dot pipe into, let's think about this. First, map double, and then map double. Maybe even we could do something like this. Map double and double in a single pipe, right? Notice that this pipe is different from this pipe. And then tap console log, right? And here we could put a filter. So here we could say something like filter, maybe even before here. We could say filter on, let's say, if x, given some x, if x is greater or equal than or equal to 0, right? And then do the mapping and then tap, right? So something like that is sort of where we want to go. And this is kind of what RxJS really looks like. Let's see if we can find some kind of example here. Yeah, okay, but now we're at but let's go. I'm just Googling RxJS. Let's just see if we can quickly find an example of something like this. So I want to look, get started. Sorry, I'm not super familiar with these docs. Yeah, no, this is not good. Installation overview. What we want to have is purity flow, la la la. No. Okay, so let's just go RxJS operators. It's just to see whether I'm completely off the mark here or not, right? RxJS operators by example. Let's see if we can find map here. So map, right? Apply projection, blah, blah, blah. Yeah, and this is what we're talking about, right? So assuming that you have some source that will emit values, some kind of observable, and then, yikes, I could not zoom in that much, apparently. Okay, final thing, like that, okay. Then you could say, let me take my source observable and pipe that into another observable that will map everything that's given to it through this function and then emit new values, such that I could observe that observable instead, right? So that I could say, if I do this piping, then this observable is going to return me a new observable. So let's say, I don't know, like filtered and mapped, right? Or like, let's actually just say this, less than, or let's say non-zero, right? Non-zero is the result of, and let's simplify this. Let's say by piping into the function filter, where where for every x you ask if x is greater than zero, greater or equal than zero, right? Let's remove that other stuff. So then this should give me back a new observable, right? And I should then be able to subscribe to that observable instead. So instead of actually subscribing to this initial observable, I'll just subscribe to non-zero. Non-zero, which is sort of an aggregate. It's sort of this observable that's built up from observing another observable. I'll subscribe to that, and whenever that thing emits values, right? Maybe here I'll say subscribe, and then maybe tap console log, right? So like whenever that thing, actually I could just say console log here. It doesn't really matter. Console log, right? So whenever that thing emits values, I should get values out. And now the goal here would be not to get 10, 1, negative 1, 2, 3, 4, but it would be to get 10, 1, 2, and not negative 1, right? Because we're filtering here. And so, I mean, if you think about that, how would you do that if you're not using maybe types, and if you're not sort of hard coding that the function that I want to call is this particular function? Like, it's difficult to express this sort of disappearance of a value using the pipe operator in functional programming, right? Because you have a value and you have to do something with that value. So if you want to say suddenly there's an absence of this value because I've filtered it out, then you need to use something like a maybe type or something along those lines, right? But yeah, or you could do it this way, right? You could, but here we're sort of embracing mutation, right? Imperative shell. And we're saying then, let's just pipe data from one place into another place, and let's ignore the stuff that we don't care about. And that's the way we're going to implement filters. So let's do that next time. Let's cut here, and please, and I'll be back tomorrow, but please let me know in the comments if you have any questions about where we've come to, or what's been happening in this video. I'll see you tomorrow, and you know what to do. Let me know in the comments, and hit the like button if you appreciate the video. Remember to subscribe, and I'll see you in the next one. Ooh, wrong button.